Here we're going to look at the Henderson-Hasselbalch equation and how it's derived. Obviously, the Henderson-Hasselbalch equation is a very useful equation and it allows us to work out the pH of a buffer. We're going to look here at acidic buffers, and if we look at the acid dissociation constant, and that's equal to the concentration of hydrogen ions times the concentration of your salt ions divided by the concentration of your weak acid. Now, first thing we need to do to get the Henderson-Hasselbalch equation is we need to make H hydrogen ions the subject. So H plus then is equal to Ka times concentration of HA divided by the concentration of A minus. And this is an equation, if you've done A-level chemistry, buffer calculations, this equation here should be familiar. But what we're going to do is we're going to transform this into the Henderson-Hasselbalch equation, and we can do that by minus log each term. So if I minus log each term, what we get then is we get minus log of the hydrogen ions equals minus log of the Ka. And then log rules will dictate, and you should be aware of this, hopefully, that A times B, if I log them, it'll become log A plus log B. That's just simple log rules. So in effect, this multiply sign will turn into a plus. So plus, and remember with minus log and everything, minus log, and that's HA over A minus, or the concentrations of HA over the concentration of A minus. So obviously what we can do is we can, this plus minus term here, plus and a minus obviously makes a minus, so I can get rid of that and just put a minus there. Just move that a bit closer. So that now is part of the way towards my Henderson-Hasselbalch equation. Minus log of the hydrogen ion concentration is pH. Minus log of Ka is equal to pKa. And then we got minus log of the concentration of HA divided by the concentration of A minus. Now that is almost the Henderson-Hasselbalch equation, and you could in effect use this to work out the pH of a buffer. You may, however, more frequently see this written as something slightly different, because what we can do is you can use some log rules. Log rules will state that minus log of A over B is equal, as the same as log B over A. So in effect what we can do is, if we change this sign from a minus to a plus, these have to be switched around. So when we do that, then that gives us pH is equal to pKa plus log A minus over and HA, concentration of HA. And that there is the Henderson-Hasselbalch equation, the one that you're most likely to see in textbooks.